have central tendency, and this is, I looked for a unit in your book, but it's kind of in the appendix. So we're just going to use from the new book that we're using next year in this school. So central tendency is a measure of the middle of a set of data. Why might you want to know the middle of a set of data? Yes? So you can kind of tell the rest of it? Mike, what would be a good place where you're looking? Where's some place where you're finding the middle?
The middle?
Yeah, the middle. How about in baseball? What do they talk about? Anyone? Or softball?
What was the question?
Oh, where do you find the middle? What's the batting average? Is that 4.4 is the batting average? 0.40? Or is that your ERA? Batting, so 400, when they say she's batting 400? That's pretty good, right? Yeah. So that means, so your batting average is out of all the times that you get up to bat, okay? What is the average percentage of the time that you get a hit, right? So that, if you're looking for baseball players, that might be a good measure of central tendency. If you're shopping at Costco, you ever go to Costco and you kind of have weird sizes or something like that? They don't have many weird sizes because they kind of look for the middle, you know? And like I kind of have short legs, you know, and I'm always looking for pants for myself. But and so I can never find my size because most people have like longer, their legs and their waists are pretty proportional. Me, I'm out of proportion. So at stores, they try to stock the most common sizes, right? Because they don't want to, because probably they could get, because not that many people will buy the other size, stuff like that. How about another place you see that averages, middles, is in housing. You know, they say the median price of a house in Louisville or Superior is so much, or the mean price of a house in Louisville is so much, or so much, or the mode is something else. So we're going to talk about those. So this is all about central tendency. How many of you have seen this stuff 100 times already? That's a couple times you've seen it before, mean, median, mode. Okay. So you have three measures of central tendency. Okay. Do you know about an outlier? Outliers? Outliers are values that are way out of the average. Okay? So if you are like Kobe Bryant in basketball, you know, like everyone's averaging like 20 points a game or 10 points a game or 15 points a game, and Kobe Bryant, he's averaging like 40 points a game or something like that, he's an outlier. Okay? Or someone that's really, really tall in a group of people, that's an outlier. Or someone who's running who's like way faster than everybody else, that's an outlier. Or in a house, you know, if you're in the housing market and all the houses in your area cost about, I don't know, $300,000, and then there's one house that costs like $10 million because they built this super huge mansion on the hill, that's an outlier, right? And that kind of throws off your data and stuff like that. And a lot of times you throw that outlier away when you're computing the average. Okay? The mean, you know what the mean is, right? The mean, yeah, you should probably be writing this down, is the sum of the values divided by the number of values. Yes, sir?
So it's the average.
The average. Okay? Another word for the mean is the average. Okay? It's the average. Average. So, like a lot of times I'll say the average in this class is 75% for this test score or something like that. I take all your test score. How do I do that? Yeah?
Take all the test scores and divide.
Add them up and divide. Now, yeah, and what happens with the average, like our average on the last test was kind of not so great, and then when there's people missing, those go in as zeros. Like Infinite Campus calculates it for me, you know. But my average is really bad because there are like 7 people that haven't taken their test yet. So I'm like calculating 70s and 75s and stuff with a bunches of zeros. So that dropped my mean way down low. Said, oh, they haven't taken the test yet. So average, the mean, the sum of the values divided by the number of values. Okay? The median is the middle value, the average of the two middle ones. The mean is the middle value, okay? So if I have, say, some numbers, let's put some numbers up here. 3, 5, 7, 2, 8, 8, 9, and 4. You have to find the middle value. What's the middle value? Yes, sir.
2.
Is it 2? No, it's in the middle, but it's not the middle. So when you're doing the median, you have to arrange the values from smallest to biggest and then find the middle. So I'm going to take these numbers and arrange them from smallest to biggest. So I'm going to go 2, 3, what's next? 4, 5, 7, 8, 9. All right? Now where's the middle? Now where's the middle? 5. So this would be the median, okay? Half for below, half for above. That's the median. If you're driving down the highway, what's the median? Yes? The middle, yes. When I was a kid, my dad said, why don't you go play on the median all the time? It wasn't very nice to me. Okay. No, I'm just kidding. He said, why don't you go play in traffic? All right. And I didn't even. So anyway, now what if I had another number up here, like this, and I have an even number? And then where's the median? We had so there's an even number, right? 2, 3, 4, 5, and then 7, 8, 9, 10. So if there is no middle, you take the two that are in the middle, and then you take the average of those two. So I go 5 plus 7. So you take the mean of the median, okay? And so that would give me 12 divided by 2. So the median in this set is actually 6 if I were to add a number out here. Do you see that? So if there's an even number in the median, you add them all up and you divide by 2. If there's an even number of numbers, then you find the two that are in the middle and then you take the average of those two, the mean of the middle, the mean of the median. Okay, and what else? The mode is the value that appears most often. Okay? So if I have a bunch of numbers, so 3, 5, 5, 8, 8, 8, 7, 9, 11, 11. What's the mode? 8, because it appears the most time. So like I was saying, like if you're at Costco and you find out that size 12C is, people are just buying 12C size shoes all the time, you would probably, and you were the manager at Costco, you would probably want to go with the mode, because that's the most, people are buying the most of those. So with mode, it's more like you can use more with non-numerical data, like colors, like 5 people. Never mind. Well, we'll talk about it as we come to that. All right. So now, what's that? I don't want to show you that. I want to go on to my next page, which is, can you see that? Not really. So this I cut and pasted from the new book. See these nice pictures you get in the new book? It says bowling. What are the mean, median, mode of the bowling scores below?
Mr. Leader, we can't.
I'm going to make a big, am I in the way? Is that what, I can't see that either. It's pretty small. But I'm going to try to make it bigger. Okay. So, can you see that now? The numbers? A little bit? No? Well, I'll tell you what they are. Okay? So here's some bowlers, and it says, what are the mean, median, mode of the bowling scores below? Which measure of central tendency best describes the scores? So, first thing, let's find the mean. So how do I find the mean? Yes, someone other than Justin. Anyone other than Justin in here?
What was the question?
Sarah? Add them all up and divide by what? So if I did that, I went 104 plus 117 plus 104 plus 136, thank you, Hannah, plus 189 plus 109 plus 113. They don't have my bowling square up there. Usually I don't break 100 when I go. I never said I was good at bowling. One time though, I got in the group and I got like over 200. And then after that, I don't think I ever broke 100 again. It was like weird. It was just like somehow it clicked. Anyway, so you add all those up and you divide by 8. You want to do that? Should we use a calculator? Did you do that already?
I don't know if I got it right.
Let's see. I don't know if I got it right. I didn't do this. I need a calculator. 104. What'd you get? Plus 117. Plus 104 again. Plus 136. Plus 189. Plus 109. Plus 113. Plus 104 equals, divided by, that's not right, I missed one. What do you get, Justin?
I got it wrong.
You got it wrong.
Because I did it in my head.
Oh, you did it in your head? Oh, do I have to do this in my head? I just added something wrong. I think I forgot the 113. No, I didn't. 104, 113, 109, 189, 136, 104, 117, and 104. I got 96. Oh, divided by 8. I did do it right. Divided by 8. I got a mean of the mean. I got to be 122. Did you guys get 122? That's what you should get. Okay? Let's figure out the median. Okay? The median, I'm going to go, I don't need this down there. The median, I'm going to find the middle. So I'm going to list from smallest to biggest. And if there's a repeat, I have to repeat it 3 times. 104, 104. So I've used all my 104s, right? Then what comes next? 109. What's next? 113, right? And 117. I have 8 numbers yet? No. I have a 136. And then I have a 189. Okay? And is that 8 numbers? 1, 2, 3, 4, 5, 6, 7, 8. Now notice, in this case, my median occurs at 2 of the same numbers. Okay? Right? So I add those 2 up. I go 109 plus 113, which gives me 222. And then I divide that by 2, and I get 111. And that's the median. What's the mode? 104, because it appears the most. So, which do you think is the middle? Okay, which do you think is the best measure of the middle in this case? What do you think? Is there an outlier? Which is the outlier? The 189 is kind of an outlier because it's like way higher than all the other numbers. So when you have an outlier, the median is a better measurement than the mean, because what happens when you have an outlier is it throws the average off. You know, if you have a number that's way bigger than the other number, then it throws the average off. So if your neighbor makes $10 an hour and your other neighbor makes $11 an hour, and someone else makes $15 an hour, and then you have the other guy who's like a brain surgeon who makes like $3,000 an hour, you know, and you're trying to take the average salary or in your neighborhood or something like that. This guy, he doesn't really count, you know. You say, oh, he's a brain surgeon, you know, he makes way more than anyone else. So anyway, so when you have an outlier, the median is kind of a better measurement tool than the mean. All right, and that's the same case thing with housing, because with houses, kind of most of the houses, in Louisville, they're kind of like the same amount, more or less. But then there's like that one overlooking, I was driving to work this morning, down McCaslin. Have you seen? There's this one that looks like a castle. It's like crazy. It's like, it must be like 30 people must live there or something. Anyway, that's an outlier. Is that your house, Jordan?
No.
That's not your house. Is someone who goes to school? Is that someone's house?
It's like my house is like as big as their garage.
Their house, I know. Well, like me, I have a piece of plywood down by the railroad tracks that I live in, and so I don't really, No, I'm just kidding. Okay. Your grades on 3 exams are, I want to move on. So your grades on 3 exams are, so this is kind of a tricky problem. Okay? Your grades on 3 exams are 80, 93, and 91. What grade do you need on the next exam to have an average of 90 on the 4 exams? Do you guys know how to do this? Because this is what kids are always asking me. What do I need on the next test to have this as my average, right? And so it's not magic, it's math. Okay? So what you do is you got to let x equal something. Let x equal the next exam. Next exam grade. An exam grade. And then, I think we did this first semester, but we have an 80, plus then we have a 93, plus we have a 91, plus we have an x, right? An x, which we don't know. And we want to divide that by how many? 4, because altogether you're going to have 4 tests, right? On 4 tests, to have an average of 90. So that's the way you set this up using algebra, right? It says your grades on 3 exam are 80, 93, 91. What do you need on the next exam to have an average of 90 on the 4 exams? Okay, so do some math. Anyone know how I get rid of this 4 down here? How do I get rid of that 4? Good. I multiply both sides by 4. Okay? So I don't need this thing. How do I get rid of this thing? Because I gotta see how do I get rid of this? Close this. There. I'm gonna multiply everything by 4. And when I do that, this 4 goes away. And this turns into a 4 times 90. So I get 80 plus 93. Really simple problem, but people have trouble with this. Plus 91 plus x equals 360. Now I put all this stuff together. And so when I add those 3 together, that gives me 173 plus 91, 264, I believe. 264 plus x equals 360. And now I subtract 264 from both sides. Minus 264, minus 264. And I get x equals 360 minus 264, which is 96. So in order to have an average of 90, you need to get a 96 on that last test. Okay? For some of you it is, what grade do I need to get on the last test on the final to get a C in the class, or to get a B in the class, or something like that, right? So we'll talk about that when the time comes. But that's basically how you do that type of problem. You'll see lots of those on your homework. Do I have an example like this? Let's see. No. Okay? Something else, measure of dispersion. Dispersion means how far apart things are. Okay? So how it describes or spread out the values in data are set up. One measure of dispersion is the range. The range of a set of data is the difference between the greatest and least data values. So in order to find the range, the closing prices in dollars for 2 stocks for the first 5 days of February are shown below. So 25, 30, 30, 47, 28. The range is 22. They've talked about this a lot in the stock market. Okay? if one person is 7 feet tall in this class and one person is 4 feet tall, what is the range of heights in this class? The tallest person is 7 feet tall. That would be me. And the shortest person is 4 feet tall. What's the range of heights? 3. You just subtract 7 minus 4. That's the range. So in here, they're looking at stock prices and how this particular stock jumps around. And it has a range of 22. Its mean is 32. Okay? This stock, okay, its range goes from 34 to 28 to 36 to 31. And this has a range of 8. So, but its mean is the same. So I add up those 5 values and divide by 5. So which stock bounces around more if I were looking at stocks? Which one bounces around more? Hi, Mrs. Hine.
Hi, Mr. Leader. How are you?
Good. How are you? Moving on. So this stock bounces around a lot because it's a much bigger range. So if you were like to look at the chart on it, it would kind of be going all over the place like this. This one, if I were doing this stock, it would still have the same average, but it would bounce a lot less. Okay? And some people, if they like risky stocks, they kind of invest in this kind, and some people invest in this kind. I would make you do this one, but I'm not going to make you do it. This is a you try I was going to do. They call it got it instead of you try, but it's kind of the same idea. Okay. Then here's a way to find the measure of central tendency from a. This is called a line plot. Okay. So if you have televisions per household, so it says the result of a survey on the number of televisions in students' households are shown in the line plot. Calculate the mean, the median, and range of the data. So this example is all kind of done for you. But what you're given is this set of data here. So what this means is there are 2 people who have 1 TV. In this survey taken, there were 2 people who had 1 TV. 2 TVs, there were 1, 2, 3, 4 people who have two TVs. This one says 3 TVs. There's 1, 2, 3, 4, 5, 6 people who have 3 TVs. 4 TVs, 1, 2, 3, 4 people with 4 TVs. 1, 2, 3, 4 people have 4 TVs. And how many people with 5 TVs? 2. So to find the average number of TVs, I have to multiply. There's 2 people with 1 TV, 4 people with 2 TVs, 6 people with 3 TVs, 4 people with 4, 2 people with 5. So this would give you the total number of TVs up at the top up there. Follow that? And down here, what's this? What's at 18? The number of surveys taken, or household surveys taken, or people, right, in that case. So I divide by the total number of people, which is just the number of X's up here. Okay? So there's 18. So it appears that the total number of the average number of TVs per household is what? What's the total average number of TVs? 3. Okay? The median, what they did is they put all this data in a line. So they went 1, 1. So this is 1 TV, 1 TV. And then they list their 4 twos. 1, 2, 3, 4. And they list their 6 with 3. And then they list their 4 with 4. And then they list their 2 with 5. The median, and then they found the middle. And when I average 3 and 3, what do I get out? What's the average of 3 and 3? 3, right? So the mean and the median are the same. And the range is 4. So it goes from having 5 TVs down to having 1 TV. So the range is 5 minus 1, which is 4. The mean is 3, the median is 3, the range is 4. How can you tell from the graph that the mean and median are equal? And the answer is right there. I should have asked you. But if it's symmetric, meaning there's the same number on this side and this side, then the mean and the median won't be the same. Okay? We're going to go on to the next page, and then I think I'm done. The line plot. Could you do this? Do you want me to do this? Are the mean and the median going to be the same in this one? Are the mean and the median going to be the same? Looking at the graph. No, because it's not symmetric. It's more like, would you say that, what is this? The line watch is the number of students in each homeroom at Jefferson. If you had a guess, what would you say that the mean would be in this case? What would you say that the mean would be? About? Just looking at the x's, the mean, so this is number of students in the classroom. What would you say that the mean would be? About, guess. Maybe 21? Yeah, maybe 21 would probably be pretty close to the mean because there's a lot of those. There's some above, there's some below. I think maybe closer to 20, right? Because it's more kind of weighted over here than up here. I think it would be more like between 20 and 21, I would say. And you can find both of those things. Should we try this? I think we should try them. Okay? So, well, I don't know if we have time, so let's not try. But you could, if you want to find the mean, I would go, what times 19? How many times 19? How many people do I have? How many classrooms with 19 people in it? 4. So I go, if I want to find the mean, I go 4 times 19, the mean, sorry, plus 5 times 20, plus 1, is that 6? 6 times 21, plus 2 times 22, plus 2 times 23, plus 1 times 24, and then I divide by the number of x's that there are. 1, 2, 3, 4, 5, 6, 7, 8, 9, 15, 17, 19, 20. And I divide that number by 20. And that would give me the mean number. If I wanted the median, I'd list 19, 19, 19, 19, and I go all the way up until I get to the last one at 24, and then I find the mean. Yes? All right, and probably in that case, the mean and the median are the same. Okay, user data, oh, that's something else. What's this? What's that? Class results, line plots, which class has a higher standard? I would guess this one. And I think then we're about done. Are we about done? We're about done. Okay. So that's kind of what your book did. We had more U tries, but we're not going to do those here. So we're going to stop and